to the elementary folks. When I spoke to the high school folks, it was still morning.
Yep.
Right?
Yep, that's right.
So good afternoon for the first time, some of you. Man, thank y'all for being patient with me and giving me these various opportunities. First session I did this morning was about classroom management. It was less about classroom management, more about classroom culture. I believe if you build the right classroom culture, the classroom will, in a lot of ways, manage itself. Second session I did was all about social and emotional learning. That there's a very significant link between the emotional well-being of the students in our class and how they perform academically. And there's research behind it to back it up. And there are things each one of us can be doing in our classes, regardless of subject or level. Elementary, middle, high, senior, gifted, special needs. Various different things each one of us can be doing in our classroom to take care of the kids in our class emotionally so that they're prepared to perform academically, without missing our chance to actually teach the standards. Remember this? And then I did a keynote with the high school folks that was just about being a superhero, right? Going to school and trying to change kids' lives. And I did the same thing with elementary kids, elementary teachers. And that is the last one. It's my last one today. I'm getting ready to shoot my last bullet. But this one's supposed to be about science, right? Is that true?
Yes.
So I'm making a big assumption here that the folks who have come to this might be science teachers. You don't have to be science, don't run off.
And this is 3D science
Oh, okay,
instruction. She's an art graphics.
No, stick, yeah, stay. You don't have to be science. And that's why I asked that, right?
I wonder why y'all are in here.
So raise your hand if you are science. Let me know that. Okay, cool, good.
That'll be everyone else.
And without putting you on the spot, raise your hand if you're not science. I do want to know what it is you teach or what it is you do.
I teach graphic design.
Oh, fantastic. That's we can call that science, no?
I teach fifth and elementary, so I teach everything.
All of it. Perfect.
I teach math.
Math, good.
Math.
2 math, graphic design, and we have.
I'm a media specialist. I teach information literacy skills, and that's what this is too. So
Perfect.
understanding information.
Oh, thank you. So, the title, I don't remember what the title of this was when I submitted it. What was the title? Anybody know?
3D.
3D science teaching, right? Good. That is what I'm prepared to talk about. Probably more going to talk about improving performance in science classes, improving student performance. This session will be a lot different than all of my other sessions, right? My other sessions, I'm doing a lot of, talking and yelling and walking around and high-fiving and I still will be myself, but this one is more of us talking together. Less of me talking. So please be ready to answer questions, give me your ideas, we'll exchange ideas. This is one big group discussion, this one. You ready?
Yes.
The only thing I want to do is this. How many people got that text message 2 days ago?
Nope.
Good. I'm afraid that I didn't get it. It makes me incredibly nervous. If that text message is supposed to tell us what to do in case of an emergency, I'm in trouble because I didn't get it. I like the fact that we have a system like that we can notify everybody in the nation, hey, we know that Japan has launched a missile and it hasn't gotten here yet, and let's all hunker down, let's go hide, or whatever it is we need to do. That's incredibly important. Not to be political. I'm very apolitical. I'm not saying that. But I think all of us ought to be able to agree that from a safety perspective, that makes good sense, yes?
Yes.
Which got me to thinking about nuclear explosions. And so now I want to ask you guys this question. What about nuclear explosions? They're all really fun to watch. We all hope that we never experience one, right? I don't want to be near any one of them, but they're fun to watch. What makes a nuclear explosion a science topic? And this is the beginning of the parts where you yell out.
Fusion and fission.
Huh?
Fission and fusion.
Nuclear fusion and fission. Good? Okay, hold on. Let's do it this way. Well, no, yell it out. Nuclear fusion and fission. Somebody else.
Atoms.
Atoms. Because the atom is being split in the bomb. Somebody else.
Symmetry.
Huh?
Symmetry.
Symmetry. That must have been the math teacher, right? No? Symmetry. Why?
When you look at the mushroom cloud that's symmetrical.
Very symmetrical shape. Anybody else?
Chemical
chemical damage and medical problems, the radiation that causes cancer, and
After effects.
after effects. Good. Anybody else?
The effect on every living thing.
Huh?
The effect on every living thing.
The effects on every living thing can make this a science topic, right? Imagine, though, that you guys were in like 8th grade physical science. And I said, yesterday, we talked about different types of energy. You guys remember this? We talked about different types of energy. And now today, I'm opening up class with this picture of a bomb explosion. And what I want you to do is, for the next 5 minutes, let's ask some questions that will help us understand how a bomb explosion is related to types of energy. What are some possible questions we could ask? Anybody?
You could just say, what types of energy do you see?
What types of energy do we see in the picture? Is a great question. Somebody else.
Where does the energy come from?
Where does the energy come from? So the energy that's released from this bomb came from somewhere. Where did it come from?
How much energy?
Where does the energy from this explosion go? Somebody said that. Who said that? Where does the energy from this explosion go? Is that a scientific question? Yes. Is that something we can figure out? Possibly, maybe? Yes.
How
right?
much energy is produced?
Huh?
How much energy is produced?
How much energy is produced from an explosion like this? Is that a scientific question? Yes, very good one.
What kind of energy makes the what different energy levels make the different colors you see?
Oh, I see the connection to art, right? It's very STEAM, right? Very graphic design. But why? What types of energy make the colors we see? Why is it brighter at the top and darker at the bottom? Why is some of it yellow and some of it red? What are some other scientific questions we could pose that we can ask that will help us understand how this bomb explosion is related to types of energy? Let's get one more, then we'll move on. Anybody? 5 extra points to the next quiz. Somebody asked a scientific question that we could pose if we were 8th grade students.
What happens right after?
What happens right after an explosion like this? You go deeper. Be more specific.
What, in the sense of what happens to the energy around the spot right after?
What happens? How does this explosion affect the energy right around it?
Energy growth and decay.
Huh?
Energy growth and decay.
Energy growth. But put it in the form of a question.
Like, what would be the best model for the decay of the energy after the explosion?
What would be the best? Give her a snap. For a reason that I'll tell you guys later. Give her some snaps. What would be the best model for the energy
Decay.
decay? Good. All right, let's move on. I'll come back to this in a while, and you guys will see why I just did what I just did. This is all about raising student performance in science. And the truth of it is this. I have a new role in my school system that I kind of like, but I kind of don't like. I'm in my 3rd month as the science coordinator for Douglas County School Systems. We have 8 middle schools, 6 high schools, and 20 elementary schools. And the superintendent has tapped me on the shoulder and he said, Casey, it is your job to raise science scores for our district.
No pressure.
Yeah, no pressure, right?
Bless you.
Not only raise the science scores, but we need to see a change the next testing cycle. Well, I didn't make it happen. And the presentation I'm sharing with you guys today, the reason why it's connected to 8th grade standards, I could have made this for 5th grade or 3rd grade or 2nd grade or high school biology or anything. This very honestly, my hand to God, is a presentation that I shared with one of my middle schools. We had the 6 science teachers from Yeager Middle School in a room with me 4 days ago. And I began with them the very same way I've begun with you. Everything I'm going to share with you guys in only 15 more minutes, I think, 20 more minutes, is what I shared with them. If we're talking about raising student performance in science, how do we do it? Okay? Now, one of the things I asked them to do, that I won't necessarily ask you guys to do, but I'll tell you what I asked them to do. I passed out a post-it note to all of them, and I asked them, by this point I've already been in each one of their classrooms 2 or 3 times and observed them teaching, blah, blah, blah. And I gave them a slip of paper and I said, jot down the obstacles that hinder student performance in your class. What are the barriers? And then let's talk about it. You know, I am going to do it. Let's do it. I told you this is one big discussion. What are the barriers that hinder student performance in science for your school or for your class?
Time.
If you're courageous enough to yell it out.
Time.
Time. Be more specific.
I have my students for 30 minutes for science.
30 minutes for science in elementary school is just not enough time to do it. I'll accept that. Anybody else?
Language.
Language. Be more specific.
We have students that are not English speakers that have very little English or, so.
English as a second language is a language barrier, and science doesn't help because it has really big words.
Cell
Right.
phone distraction.
Huh?
Cell phone distraction.
Cell phone distraction. I'll take it.
I think when you're talking about language, not just new to the country language, but socioeconomic, your background really affects you.
I would definitely agree with that. Some kids have never experienced some of the words that science talk about, right? If my parents make more money and have taken me to see a volcano before, then I'm already as an advantage to a kid who's never left Alton. My mom and dad took me to see a waterfall one time before, so I'm at an advantage to a kid who's never seen a waterfall, especially if Mr. Bethel chooses to use waterfall as the example in class, assuming that every kid knows what a waterfall is, right? Hey guys, when potential energy changes to kinetic energy, when the